Hey everyone, and welcome back to the channel. Today, we're diving into a topic that's literally all around us, yet mostly invisible. We're talking about the electromagnetic spectrum. Now, I know what you might be thinking, science class flashbacks. But trust me, this is way cooler than you remember. It's a story of invisible forces that shape our entire world, from the food we eat to the way we talk to each other across the globe. So, what exactly is the electromagnetic spectrum? Imagine a giant, cosmic rainbow. The tiny sliver of color we can actually see, the visible light, is just one small part of it. But beyond the red and violet, there's a whole universe of other colors or waves, each with its own unique superpower. It's like having a secret menu of cosmic energies. These waves are all made of the same stuff, photons, but they vibrate at different frequencies and carry different amounts of energy. Let's start at the long, lazy end of the spectrum, radio waves. These are the marathon runners of the EM world, with wavelengths that can stretch for miles. They don't have a lot of energy, which is great because it means they can travel huge distances without getting tired. Every time you tune into your favorite radio station, listen to a walkie-talkie, or even use your garage door opener, you're using radio waves. They are the unsung heroes of long-distance communication. Next up, we have microwaves. And no, not just the box in your kitchen that heats up leftovers. Although that's a perfect example of their power. Microwaves are a bit more energetic than radio waves. They're fantastic at making water molecules jiggle, which generates heat, and that's how a microwave oven cooks your food. But they also power our modern world in other ways. Your Wi-Fi, your cell phone signal, even weather radar. They all rely on microwaves to send information zipping through the air. So next time you're scrolling through social media, thank the microwaves. Moving on, we get to infrared radiation. You've definitely felt this one before. It's the warmth you feel from the sun, a cozy fire, or even another person. Everything with heat gives off infrared waves. This is why thermal imaging cameras work. They don't see light, they see heat. Firefighters use them to find people in smoky buildings, and scientists use them to study heat patterns on Earth from space. Even your TV remote uses a little pulse of infrared light to change the channel. It's the language of heat, and it's happening all around us. Then, we arrive at that tiny, beautiful slice we call visible light. This is the part of the spectrum our eyes have evolved to see, from red to violet. It's how we perceive the world in all its glorious color. Every shade, every hue, is just our brain interpreting different wavelengths of light. It's pretty amazing that our entire visual reality is confined to such a narrow band of the full spectrum. It makes you wonder what the world would look like if we could see the rest of it, right? Now, let's step beyond what we can see and into the high-energy zone. First up is ultraviolet, or UV light. We all know this one from the sun. It's what gives you a tan, or a sunburn if you're not careful. UV light has more energy than visible light, enough to cause chemical reactions. This can be harmful to our skin, which is why sunscreen is so important. But it also has some cool uses. It's used to sterilize medical equipment, and some animals, like bees, can actually see in ultraviolet to find nectar in flowers. Cranking up the energy even more, we hit X-rays. These waves are so powerful they can pass straight through soft tissues like skin and muscle, but get stopped by denser materials like bone. This is exactly why they're a medical superstar. When you get an X-ray for a broken bone, you're seeing a shadow picture of your skeleton. Airport security scanners also use X-rays to see inside your luggage. They are our go-to tool for peering inside things we can't open. Finally, at the most energetic, most powerful end of the spectrum, we have gamma rays. These are the heavyweights. Gamma rays are generated by the most extreme events in the universe, like supernovae, neutron stars, and even nuclear reactions here on Earth. They carry so much energy that they are incredibly destructive to living cells. But, harnessed carefully, that power can be used for good. In medicine, a focused beam of gamma rays, called a gamma knife, can be used to destroy brain tumors without ever making an incision. It's a prime example of turning one of nature's most powerful forces into a life-saving tool. So, from the long, gentle radio waves that carry our favorite songs to the powerful gamma rays forged in dying stars, the electromagnetic spectrum is a hidden architecture of our universe. It connects everything. Understanding it isn't just about passing a science test. It's about seeing the invisible forces that enable our technology, reveal the secrets of the cosmos, and even save lives. It's a reminder that there's always more to reality than what meets the eye. Thanks so much for exploring the invisible world with me today. If you found this fascinating, hit that like button and subscribe for more deep dives into the science that shapes our world. Let me know in the comments which part of the spectrum you think is the coolest. See you in the next one.